Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Firstly, I will introduce myself. My name is Dzulfan Hazim bin Adzwan, and I am from DMA 43 Charlie, and my alam ID is 018882, and I'm here to present to you about my final 3D modeling final project, which is using SolidWorks, and the parts of or the machinery that I choose for this project is pneumatic motor. And lastly, I hope we can learn something about how to use SolidWorks and how to make something or parts of using SolidWorks. So please enjoy my video.
Okay, let me start for the first part of the project, which is the base plate. I sketch a rectangular shape here from the midpoint, and the width of the rectangular shape is 50 mm, and the length of the rectangular shape is 82 mm. And then I go to the extruded boss feature, and I extruded this rectangular shape for 16 mm height, and it will be like this. It will be a box. And then there's a 4 tap hole on the top of the base plate. So first I make a center line between this line between this and this point, which is 41 mm, and this point to this point is 25 mm. And I sketch a hole here and here, and I'm mirroring it, and it will be 4 hole here, and the length of between this hole and this hole is 38 mm, and this hole and this hole is 35 mm. So I choose the standard and the tab hole type. The size is M4, and I put the length, the hole length is 8 mm, and the thread length is 6 mm. And so it will be like this. So it will be like this. And then I choose the features, the chamfer features. I go to the top plane of the base plate, and I choose 4 edge, which is this edge, this edge, this edge, and this edge, and I put it for 5 mm, and the degree is 45 degree, and the final result it will be like this. We move on to the second part of the pneumatic motor, which is the mounting bracket. So I made a line here to here, and up to here, and here to here, and down here to here, and here to here. And then I choose these two lines to be collinear and equal, and I put the length between this point to this point is 48 millimeter, and this point to this point is 24 millimeter, and this point to this point is 16 millimeter. And then I go to the features, the sheet metal features, and I choose base flange, and I put it in the blind direction, and the length is 35 millimeter, and it will be like this. And I choose extruded cut features. Before that, I sketch on the top plane of the mounting bracket. The sketch is 14 millimeter, and here the length is 28 millimeter, and then I go to the extruded cut feature, and I cut the sketch that I sketched before on the top plane of the mounting bracket. I cut out this sketch, which is 14 millimeter. Not 14 but 4 millimeter, sorry. And then we move to the top plane of the mounting bracket. So I'll choose to make a hole, and the position of the hole here, as you can see, I put it this hole, and this hole is 28 millimeter, and the length between this hole and this hole is 35 millimeter, and the length between these two holes is 8 millimeter, and the length between this hole and this line is 8 millimeter. And I put this hole, this midpoint, to the until here is 5 millimeter, and also here midpoint till here is 5 millimeter. And then I chose a standard is DIN. The type is drill size, and the size is 4 diameter, and then the end condition is true all. So we click right, and it will be like this. So we move on to the third part of my project, which is motor block. So I start to sketch with a line from the midpoint. I make a line from this point to this point, and then up to this point, and then move to the right, and I make a line down to this point, and then down to this point, and move to the left this point, and up back to the midpoint. So we're going to sketch and choose smart dimension, and I put this length between this point to this point is 62 millimeter, and this point to this point is 40 millimeter, and I choose this point to this point is 30 millimeter, and you can see down here the length of the line is 21 millimeter, and this length is 38 millimeter, and this length is 12 millimeter. And then I go to the extruded boss feature, and I choose blind direction, and I put it 20 millimeter length, and it will be look like this. And then I choose extruded cut feature, but before that I sketch on the top plane of the motor block. I sketch a circle, one big circle and a small circle. I choose sketch and choose line here, and choose a center line, and I put a center line from here to here. And then I go smart dimension, and then I choose this point, to this point, which is 10 millimeter. And then I draw a circle from the center line, one big circle and one small circle, and the diameter of the big circle is 14 millimeter, and the small circle is 4 millimeter. And I put the length between the center line of the big circle into this line is 10 millimeter, and then I draw a line between this point of the small circle to the big circle, and also mirroring to the bottom of the circle. And then I choose extruded cut feature, and I choose this hole, tap this hole and this hole, and I choose the direction is through all, and it will be like this. We move on to the second hole that I draw before, which is the small hole. We go to the extruded cut feature, and I take this area and this area, I put it on a blind direction and put the length to 2 millimeter. And then I will do the 4 tap hole on the top plane of the motor block. First, I sketch oh, you can see here. So here is the position of the tap hole. I put here, here, here and here 4 hole, and the length between this hole and this hole is 14 millimeter, and this hole is 24 millimeter, and the length from the midpoint of this hole is 3 millimeter to the up side, and to the left side is also 3 millimeter. And then I choose the hole standard is DIN standard, and the type is tap hole, and the size of the hole is M3, and I put it on a blind condition, and the thread length is 6 millimeter, and the hole length is 9 millimeter, and it will be like this. And then you move to the I sketch the side plane of the motor block. I sketch a circle, and the diameter of the circle is 5 millimeter, and the length between the midpoint of the circle to the bottom line is 20 millimeter, and this point to this point is 8 millimeter. So I choose, and then I choose extruded cut features again, and I choose this hole, and I put it, the direction is through all on this sketch plane that I sketched before, which is the circle, and it will be like this. So we move forward to the next sketch. The front plane of the motor block, I sketch a circle here, which is 8 millimeter, and I put it on the center of the motor block, and the length between the midpoint and this line is 10 millimeter. And again I choose extruded cut, and I will cut out the circle that I sketched before, and I choose the direction is through all, and it will be like this. And here is from the back. And then I choose chamfer features and take this edge at the circle that I've cut out before, and I choose the length is 1 millimeter and in 45 degree, and I click right here, and it will be like this. After that I will make a hole. So here I choose the contour board type, and then I edit the section dimension. The diameter is 2.5 millimeter, the depth is 48 millimeter, and the bore diameter, C bore diameter is 4 millimeter, and the C bore depth is 30 millimeter, and I put the end condition is up to next, and it will be like this. As we can see here, the hole that we made here. and then remove the next sketch. Sketch two circle at the back of the motor block. So the diameter of the circle is 3.2 millimeter, and the length between the midpoint of the circle to the upper line of the motor block is 17 millimeter, and the length between two circles is 6 millimeter. And then I choose extruded cut feature, extruded cut feature, here. I choose this circle, these two circles, and the direction is up to next, and I click right here, and it will be like this. We can see from the top of the motor block, these two circles is there. And then I will make a hole at the bottom of the motor block. So I sketch two circles here and here, and the length between these two circles is 8 millimeter, and the length from the midpoint of the circle to the end line here is 8 millimeter, and I choose the standard is DIN, and the type is tab hole, and the size is M4, and then the end condition is up to next. So I click right here, and it will be like this. As we can see here, the hole that we made here is there. Okay, and we move on to the last sketch, which is on the bottom of the motor block. So I sketch a small circle here. So I will zoom in, is 2.5 millimeter, and I choose extruded cut feature, and I will cut the circle here that I sketch, and I choose the direction up to surface. I will click right here, and the circle will be there up to the next here. So the circle is there, and that's all for the third part of my project pneumatic motor, which is motor block. Next, for the next part is the cylinder head. I choose the top plane, and I sketch a rectangular shape from the midpoint, and the width of the rectangular shape is 20 millimeter, and the length of the rectangular shape is 28 millimeter. Then I choose the extruded boss feature, and I put it in the blind condition, and tag length of the extruded boss is 3 millimeter, So I will click right here and it will be like this. And then there is a 4 tab hole on the top of the uh, cylinder head. So here is the position of the hole. There's 4 holes, and the length between this hole and this hole is 21 millimeter, and the width between this hole and this hole is 14 millimeter. And I choose smart dimension, and then I choose this point to this line is 3 millimeter, and this point to this upper line is 3 millimeter also. And we go to the type, and I choose the DIN standard and the tab hole type, and the size is M3 times 0.2, and the direction is through all. And I will click right here, and it will be like this. So here is the hole with the thread. So I will make this change the transparency to look much more better. So here it is. Okay. Okay, for the next part, I will do the flywheel. First, I will make a circle, one big circle from the midpoint of the sketch. Or before that, I choose the front plane, and I made a circle from the midpoint, which is 50 diameter, 50 millimeter diameter. And then I made a construction circle which is 24 millimeter diameter, and I made this hole on the construction circle which is 10 millimeter. And I go to the sketch, and I choose linear sketch pattern and circular sketch pattern, and I choose this one circle, and it will be 4 circle here on the sketch, the construction circle. And I click right, and then I sketch a small circle from the midpoint, and the diameter is 8 millimeter. And here after that I choose extruded boss. I choose extrude boss, and we go to the front plane. So I choose this 5 hole that I sketched before to the blind direction, and I put it 10 millimeter. So I click right here, and it will be like this. After that, I will sketch at the back of the flywheel. So this circle here is 36 millimeter, and I will choose extruded cut to cut the circle that I sketched at the back plane of the flywheel. So I choose the direction is on line, and the length is 4 millimeter. So I click right, and it will be look like this. After that, I will sketch a circle at the front plane of the flywheel. here. So the diameter is 12 millimeter, and then I choose extruded boss feature to so I put it in a reverse condition and put it in a blind direction, and the length is 1 millimeter, and it will be look like this. And then I sketch on the front plane of the flywheel a circle from the midpoint, and the circle diameter is 8 millimeter, as we can see here. And then I choose extruded cut feature here, and I put it through all and in reverse condition, and put it click right here, and it will look like this. So here is the result of the flywheel. And we will move on to the next part. The next part is crankshaft. I choose the front plane of the crankshaft, and I sketch a circle from the midpoint, and the diameter is 8 millimeter. And then I put it, and I choose extruded boss feature and put it on a blind condition, and the length is 25 millimeter, and it will look like this. And then I will sketch a circle on the top plane of the crankshaft. So the circle from I sketch the circle from the midpoint, and the diameter is 4 millimeter. And then I choose extruded boss feature, and I put it on blind condition, and choose the sketch the circle that I sketched before, and put it 12 millimeter length, and it will look like this. Okay. After that, I will make a chamfer on the top of the crankshaft. I choose this face, and the distance is 0.5 millimeter, and the angle is 45 degree. I click right here, and this is the result of the chamfer. After that, I will make a hole at the front plane of the crankshaft. Here, the position of the hole, I sketch a circle from the midpoint, and the circle here, and I choose the standard is ANC metric, and the type of the hole is drill size, and the size is 3.2 diameter, and I put the condition on a blind condition, and the distance, the length is 14 millimeter. The thread length is 14 millimeter, and click right here, and it will look like this. And then I will cut. So we go sketch on the side, right plane of the crankshaft. I sketch line a rectangular here, a rectangular shape here, which is the width is 1.5 millimeter and the length is 4 millimeter, and the bottom I will sketch a rectangular shape also, and the width is also 1.5 millimeter, and the length is 12 millimeter, and the length between this point and this point is 9.5 millimeter, and then I choose extruded cut feature and go to the side of the crankshaft. I choose both sketch, both rectangular sketch, and the direction is through all, and I choose both, and it will look like this. And lastly, I will make a hole on the surface that we cut before. So I drew a circle on this surface, and I put it center, and then the standard of the circle is asymmetric, and the type is drill size, and the size of the hole is 3.33 millimeter diameter, and I put the condition is up to next, so it will look like this. So I will put here to the, I will change the transparency to see the hole. And this is the final product of the crankshaft. For the next part, I will do the crank of the pneumatic motor. First, I will sketch a circle. I choose this one, circle, from the midpoint, and I made a circle which is 11 millimeter diameter, and I made another two circle. Choose the same circle from the midpoint, and I made this circle 8 millimeter diameter, and also this circle 8 millimeter diameter, and I choose trim entities, and I remove the arc here and here, and the arc down here and down here, and there is already empty here. and then I choose a line here, and I put a line from this point at the 8 diameter to the 11 diameter circle, and also at this side, and then I choose center point arc, and from the center point I go to here and drag there and drag it to here, and this is the arc there, and then I choose the line, this line, and I connect the arc at this point to the 11 diameter circle, and also this side, and then I define all that. So the length between these two circles is 8 diameter, and this circle is 4 millimeter diameter, and this big circle is 11 millimeter diameter, and this inner circle is also 8 millimeter diameter, and the arc is 15 radius, and the vertical length from here, from this point to this point, is 4 millimeter. And then I choose extruded boss feature, go to the front plane, and I choose this surface, this one and this one, and I put it on the mid plane direction, and the length is 6 millimeter, and it would be like this. After that, we'll hit to the extruded boss again, and I choose the another circle here, which is the between the 11 millimeter diameter circle and 8 diameter circle, and I put it on the blind condition, and I put it 6.5 millimeter length. So it will be from here, from the back and to the front. So it will be like this. And this is the result of the crane. For the connecting rod of the pneumatic motor, first I do a construction line here, which is 35 millimeter, and then I sketch a circle. I choose here a circle, and I made 4 circles, which is the big one is 8 millimeter diameter, and the small one is 4 millimeter diameter, and at the right side is 6 millimeter diameter, and the 3 millimeter diameter circle. And then I made a line. I choose this line, and I made a line from the mid here point, this point, and horizontally to this point, and this 6 millimeter, and also at the right side from this point on the circle, and vertically horizontally to the left side 6 mm, and I take the mirror entities and this mirror, and it will be at the bottom also and of the both side. And then I made a line at the middle here. Here I made a line from this point to this point, and I also choose the mirror entities to mirror it to the bottom side, and I choose tangent out. So for here, so the radius of this tangent is 8 mm, and also from this line to the middle line is 8 mm. And again I choose the mirror entities and mirror it to make it same on the both side. So I define all this line between this line and this line is 2 mm diameter, and this circle to the midpoint is 17.5 mm, and also this side, this circle to the midpoint is 17.5 mm, and the total is 35 mm, and it will be fully defined. And then I choose extruded boss feature, and on the top plane, so I choose the whole sketch. So the direction is mid plane and the height is 3 mm, and it will look like this. And this is the result of the connecting road. Next, we move on to the next part of my project, which is the piston of the pneumatic door. First, I will sketch a center line on the center. Here is the center line first, and then I choose line here, and I made a line from here to up here and to the left, from this point to this point, and horizontally to the left to this point, and down vertically to this point, and move right to this point, and up to this point, and up vertically to this point, and this point to this point. So it will look like this. After that, I choose smart dimension, and I define all this, and the angle from this point, this line to this center line is 59 degree, and this line is 6.25 mm, and this line is 1 mm, and the length of this point to this point is 15 mm, and then the length of this point to this point is 11 mm, and the length of this point to the center line is 6.25 radius, and the angle of this area is 20 degree. And after that I choose the features of revolve boss or base, and from the line 1, which is the center line, and I put it the direction on the blind, and the angle is 360 degree, the whole, and it will look like this, and the piston will look like this. And then I will sketch a circle at this surface, and the diameter of the circle is 3 mm diameter, and the length between the midpoint of the circle to the bottom line is 7 mm. Oh yeah, this circle is already centered because of the center line before. And then I choose extrude cut features, and from the sketch plane, the circle sketch, I choose the direction is through all to the both side, which is this side and this side, and I click right here, and it will result of this. The result is came out like this. So this is the isometric view of the piston. And we move on to the next part, which is the crank pin. First, I choose the front plane of the crank pin, and I sketch a circle here from the midpoint, and the diameter of the circle is 4 mm, and I choose the extruded boss feature, and from the extruded boss, from the sketch plane, I'll choose the blind direction, and the length is 13 mm, and roughly it will look like this. So I click right here, and then we move on to the next sketch. So the next sketch is at the top of the crank pin. As you can see here, I sketch a circle that the diameter is 3.8 mm, and then I choose the extruded cut feature, I choose offset here, and the direction is blind. So if we choose the sketch plane, it will be like this, but I choose the offset, and the cut will be here, and I put it on the blind direction, and I will cut it on 1 mm. That. So I click right here. After that, I will choose chamfer. I will go to this side and choose this edge of the circle, this circle, and the distance of the chamfer is 0.5 millimeter and the angle is 45 degree. I click right here, and this is the final product of the crank pin. After that, we will do the piston pin for the pneumatic motor. First, I choose the front plane, and then I will sketch a circle. I choose here circle, and I will sketch this circle, and then I will make a smart dimension and put this circle into 3 millimeter diameter, and then I will go to the extruded boss feature, and I choose from the sketch plane that I sketched before, and the direction is the actual is mid plane, and the length is 13.5 millimeter, and roughly it will look like this. And when I click right, and it will be real like this, and then I will do the chamfer. So go to the features, and I choose chamfer at the fillet, and there's a chamfer here, and go to this side, so uh, so I choose this edge here at this circle, and also the other side, this here, and the distance is 0.2 millimeter and the angle is 45 degree. And when I click right here, it will look like this, and this is the piston pin of the pneumatic motor. For the washer, first I will choose the front plane, and I will sketch a circle. I choose circle, and I will sketch a circle for the midpoint, and I took a smart dimension and made the circle to the 6 millimeter diameter, and then I exit sketch and go to the extruded boss feature, which is from here, and I will extrude the boss from the sketch plane that I sketched before, and the direction is on a line, and the height of the extruded boss is 1 millimeter, so it will look like this. So I will click right, and this is the product of the sketch that I extruded was before, and then I will cut a hole at the middle of the extruded boss. So firstly I will sketch a circle. Sketch, I choose circle, and sketch a circle from the midpoint, and to a smart dimension, and I define this circle as 3.8 millimeter diameter, and then I exit sketch, and I choose extruded cut here, and this from the sketch plane, and the direction is through all. So I click right here, and there will be a hole at the middle of the washer, and as you can see here, the product should be like this. The washer is really like this. Here I will assembly all the part that I've made before. So I will put inside all my part here. So firstly I will choose base plate and the mounting bracket to put it here to attach them together. So here we can see we got the mounting bracket and the base plate, and then I will choose this hole to put it up here at the upper surface of the base plate. So I am using mate, and I will mate with this base plate hole here with concentric relation. So I finish mate. The mounting bracket is still moving there, so I will choose this hole to mate with this hole. So I click right, and this hole also to fix with this hole. As we can see here, the mounting bracket is still moving and not attached to the base plate. So I will choose this bottom surface of the mounting bracket and this upper surface of the base plate. And finally, they will attach together and not moving. So the mounting bracket is not moving. For the next part, I will insert the motor block and also I will insert the flywheel and the crankshaft that will put with the motor block. Here you can see the motor block. So I will attach this motor block with this mounting bracket. So I will choose mate, click mate, and I'll choose this hole and I will mate with this hole. The mounting block is still moving there. I will choose this another hole at the bottom of the motor block and fix with this second hole of the mounting bracket. I made it together on the concentric relation and click finish mate. So to fix both parts, I will choose this surface and this upper surface of the mounting bracket, and they will attach and fix together on the coincident relation. So I click yes, and the motor block will not moving. For another part, I will put in the crankshaft into the motor block. So I click the crankshaft here, and the hole inside the motor block. For concentric relation, I click yes, and the crankshaft will be inside the motor block. So for the flywheel, I will put it back here. So I will choose this hole and I will mate with this crankshaft here for coincident relation and click yes, and to make it not moving I will choose the surface and mate with this motor block surface here with coincident relation. So I will click yes, okay. As we can see here, the flywheel is rotating but not with the crankshaft. I will make this crankshaft is rotating with this flywheel. So I will choose flywheel here. I choose the right plane of the flywheel and hold Ctrl key and choose the right plane of the crankshaft. Right click and choose mate. And I will click yes for coincident relation. So we can see the crankshaft is rotating with the flywheel. For the next part, I will insert another part which is the crank, the connecting rod and the piston. So I will put it here, here and here. Oh, I forgot another part which is the piston pin. I will insert the piston pin. We click right here. So I will make this crank pin and this, oh sorry, I will make this piston pin and with this piston. I will put the piston pin inside the piston. So first I will make the piston pin. I choose the front plane of the piston, hold Ctrl key and choose the front plane of the piston pin. Right click and mate them together. Click right and then I choose this piston pin surface and I will put it inside the piston. So it will look like this. Click yes. For the connecting rod, I will put it inside the piston. I will attach with the piston pin. To make it easier, I will rotate the connecting rod first. Alright. So we go to mate and I choose this hole. Oh sorry. I'll choose this hole with this piston pin. Click right for concentric relation. Oh, sorry. We'll choose here and here. It will look like this. This is the real one. The connecting rod is still moving there, so I will fix it at the middle of the piston pin. So we do it again at the same as the piston that we're doing before at the piston and the piston pin. So I choose piston pin here and the connecting rod. I choose the top plane of the connecting rod, hold Control key, and I choose the front plane of the piston pin. Right click and mate them together. For coincident relation and click yes. And the connecting rod is not moving, but it will fix with the piston pin. For the next step, I will put the piston inside the motor block. So I will choose this motor block hole and this piston. Concentric relation and click yes. The piston will be inside the motor block, just moving inside the motor block. For the crank is facing a wrong side, so I will rotate the crank first. I will choose this hole and I will mate with crankshaft here with concentric relation, and the crank can be inside the crankshaft can be inside the crank hole, and then I will mate this hole with this connecting rod hole. So for coincident relation, click yes, and it will look like this. So for the next component, I will insert the crank pin and the washer. So I will choose this crank pin and put it inside this hole. So I made them together here with concentric relation. Click yes. The crank pin and the crank is still moving. I will fix the sorry. I will fix here the crank pin surface with this crank surface for coincident relation and click yes, and then the crank pin will moving with the crank. So to fix the crank, I will choose this crank surface here and mate with this motorblock surface. Yes, and then oh sorry, I will undo it. So first I will put the washer first. I will choose this inside the inside surface of the washer and the crank pin surface here. Put it here. You see, still moving, and we duplicate another washer. Just hold the control key and it will duplicate another washer. I will choose this washer surface and mate with this crank pin surface here. So click yes, so I will undo it back. Choose this washer and this crank pin. Oh, my bad. I will undo it. So I will do it again. I choose mate. I choose this crank pin and this hole. Click yes. Still moving. So I will choose mate again. I will make this surface and this here. Back. will delete it. The surface. Here. Okay, I will click right here. So I will duplicate another washer, and I click this hole, and I will make here with concentric relation and put it inside, and then I will choose this. I will choose this surface, and I will make with this continuous surface here with coincident relation, and will click yes. And also for the crank pin, I will make this surface and will mate with this crank surface. We will click yes, and for lastly I will mate this surface with this continuous surface here. Click yes and put it inside, and I will choose this surface and this motor block. No, oh sorry, we'll choose this surface and this surface together, and we make them together, and still moving. So I will fix it with mate this crank and with this motor block surface like that. So this is the result. As we can see here, the crank is rotating, but not with the crankshaft and flywheel. So to make it rotate together, I will choose the crank here and the crankshaft. I will choose the right plane of the crankshaft, hold Ctrl key and choose the right plane of the crank. So right click and mate them together for coincident relation and click yes. So finally, when I rotate the flywheel, the crank will rotate at the same rotation. For the last part, I will put the cylinder head on the top of the motor block. So I choose mate here. I will choose this hole and I will mate with this hole. Here we click yes, and the cylinder head is still moving. To fix it, I will choose this hole and this hole. For concentric relation, we'll click yes, and to attach them together, I will choose this surface and this upper surface of the motor block. Click yes. So finally, the cylinder head will not moving and attach to the motor block. For the next part, I will choose here. For the bolt, I will choose toolbox and choose DIN, go to bolt and screws, and here I will choose hexagon socket and head screws, and I choose the DIN 912. Here I will drag it here, size M4, and the length is 8. So I will click right and choose and put it on another hole. Here, put it here and here. So we got another 2 holes at the bottom of the motor block. So I will put it here and also here. Okay, then for another 4 bolts on the top of the cylinder head, I will choose the same socket, which is DIN 912. I drag it here and put it at the hole, and using size M3 and the length is 12. So I click right for the configure component and put it on all the hole. So click here, and this is the final result of my pneumatic motor. That's all from me. Thank you.